Hey guys, this is Geometry 9.6, solving right triangles. So if you're asked to solve a right triangle, what you're asked to do is find all the missing sides and all the missing angles of the right triangle. So if you're trying to find a missing side, you're either going to use trig, so that means use your sine, cosine, or tangent functions, and or the Pythagorean theorem to find the missing sides. So you can only use the Pythagorean theorem if you have 2 out of the 3 sides of the triangle. And then we're going to go through how to find the angles of the triangle. In order to find the angles, you want to use what's known as an inverse function button. So if you're taking a look at your calculator, above the sine, the cosine, and the tangent buttons, you'll see what's known as an inverse function, inverse tangent, inverse sine, inverse cosine. You use these to find the angles of a right triangle. Even more specifically, you use them to find the acute angles of the right triangle. So you still want to use the definition of sine, cosine, or tangent, but let's just say in a right triangle, you know the side opposite the angle that you're trying to find, and you know the side adjacent to the angle that you're trying to find. So kind of like we've gone over before with other right triangles, only one function involves both opposite and adjacent. That's tangent. Let's say you want to find the angle. You'd actually use the inverse tangent button. All right, so for example, in this diagram here, I have my right triangle ABC. I've given the side lengths of AC and BC, 9 and 13 respectively. I just want to find the measure of angle A right now. Even though we can technically solve this right triangle, which means find the missing side, in this case side C, and then both of the missing angles, angles A and B. Right now, just so we can get used to using an inverse function, I just want to find the measure of angle A. So here's what we do know. Okay, the side opposite angle A, the side adjacent to angle A. So like what I was just talking about, we could use the tangent. I could set this up, the tangent of angle A. I don't know the measure of angle A. That's what we're trying to find. So I'm just taking the tangent of A is equal to the side opposite over the side adjacent. So that doesn't change. But now that we want to find the measure of angle A, I'm going to use, again, the inverse tangent button. So it would look like this. The measure of angle A is equal to, again, this looks like the tangent to the negative first power, and it kind of is, but the inverse tangent of 13 divided by 9. And then on my calculator, I could just enter all that in. Since we're trying to find an angle, here's where it's especially important, even though it was important before, to make sure that you're in degree mode. So before you start typing numbers into your calculator, make sure you are in degree mode. And then you would just take the inverse tangent of 13/9. Let me show you on my calculator. So here's my tangent button right here. Above it, if you could see that, it's a little bit faint. It says tangent to the negative first power, inverse tangent. So it's a second function button. I would hit second and then see the inverse tangent. Some of you might need to hit shift on your calculator, but the inverse tangent of is 13 over 9. I do want to hit the end parentheses. I already checked to make sure that I'm in degree mode. And then that angle to the nearest tenth, if that's what I want to round it to, is about 55.3 degrees. So angle A, 55.3 degrees. Okay, even though I said I just want to find the measure of angle A, now what I'm going to do is solve the right triangle. Okay, technically I can use trig again. I would use an inverse function to find the measure of angle B, but always try to do things the easiest way possible. You know 2 out of the 3 angles in the triangle. You could always find the third, or you could just take the complement of 55.3. So 90 minus 55.3 would give you the measure of angle B, and then that's 34.7 degrees. I could actually use one of the acute angles and one of the other 2 sides that were given to find the side length C. Or, since I already have 2 sides of the right triangle, we could use the Pythagorean theorem. 9 squared plus 13 squared is equal to C squared. So 81 plus 169 is equal to C squared. Take 81, add 169 to that, and then take the square root. So 169 plus 81, 250. Take the square root of that. It's about 15.8 if I round everything to the nearest tenth. Certain things should match up as well. Here's what you can check to make sure that you're doing things correctly. A hypotenuse has to be the longest side, and it is. 15.8 is definitely more than 13, and it's more than 9. The smallest angle in that diagram is angle B at 34.7 degrees. So the shortest side should be opposite that, and it is. So that's kind of a quick way that you can check to make sure that you're at least doing things correctly.